Today I'm going to talk about LeetCode question number 416, partition equals subset sum. So given a non-empty array nums containing only positive integers, find if the array can be partitioned into two subsets such that the sum of elements in both subsets is equal. So for example, we have this first example here where we have this array and the total sum of this array is 22. And we can partition it into two subsets, such that the first subset contains 155, and the second one contains 11. With this second example, we return false because this array cannot be partitioned into equal subsets. Why? The total sum of this array is 11. That's an odd number. And how can we split the array into two subsets such that the sum of both subsets is equal when the total is an odd number? One array would also always have one more than the other, so therefore it's false. Okay. So yeah, given this information, odd will always equal false. We can write up already in our code here. Equals sum of nums if target %2 is not equal to 0, then return false. Okay, that was easy. But what if it's even? If it's even, then basically we don't have to find the exact subsets that are gonna be of equal sum. Okay, we just have to find at least one subset such that it equals to target divided by 2 . Why divided by 2? Well, if we find at least one subset, so this is 22, so this array here, total is 22. If we find at least one subset that equals to 11, then automatically the second subset should also equal to 11, because that's just how basic math works. If one subset is 11, in order to make the total of 22, the other subset has to equal 11. So really we just have to find at least one subset that equals to target divided by 2. Now let's call it target. Okay. Now, how do we find this one subset? Well, we can find it using dynamic programming. So basically, in order to find this subset, we can either take an element from the array and include it in our subset as a potential solution, or we can not take it. Okay, so for example, here we took 155. We could have also tried taking 11 in this subset, but obviously that didn't pan out. So the final solution was 155, but we want to consider all possibilities where we either take the element or leave it. This problem is reminiscent of the 0-1 knapsack problem, where it is also a take it or leave it problem, but I'll let you research that on your own time. So yeah, first I'm just going to explain here how we can use dynamic programming to get to the target here, which remember is the total divided by 2. Actually, I'll rename it. Okay. So how can we use dynamic programming to equal to target? Well, let's use this example here. I already pre-created a dynamic programming table beforehand. So this is going to be a two-dimensional dynamic programming problem, and we're basically going to go bottom up. Okay. So in order to reach this target 11, okay, so here's 11 here. And with bottom up dynamic programming, we want to solve subproblems first. Okay. So before we can reach this total of 11, is it possible to reach a total of a target of 10, a target of 9, a target of 8, etc. And we want to be able to calculate all these before we calculate 11 is because, let's say in a subset we have 5, 5, okay? these are the candidates, possible candidates in our subset, and all we're missing is a 1. Okay, so basically the problem becomes, is it possible to sum to 1? So the new target basically becomes, rather than 11, it becomes 1. So given, these two, we have 5, 5, we want to see if we can target 1. And using this bottom-up approach, we would have already calculated if it was possible to sum to 1. Okay? So that's how we're going to go about it. Each of these are going to be their own targets, and we're going to build up to the main target of 11. Okay. So how can we go about this? So yeah, as I said, we'll take we'll build the solution from bottom up. So we'll start with sum 0, or we'll start with an empty array first. Okay. So basically these elements here, they kind of represent subsets of nums. So we have an empty array, and here we have a subset of just containing 1, and then this subset would include here, would be basically 1, 5, and this subset here would be 1, 5, and 11, okay, etc. So basically, using these subsets, is it possible to total to all these ranges, or all these targets? Okay, and obviously I didn't write it out this way just to be clear, but this is essentially what this rows signify, the values in this row. Okay, so let's start with an empty subset. So with an empty subset, is it possible to sum to 0? Yes. Why? Because we basically need no elements to sum to target 0, and our empty subset already has no elements, so this is true. With an empty subset, can we total to 1? No, because we need an element, preferably like 1 or something, to be able to sum to 1. So it's not possible with an array of empty values to total to 1. And it's the same thing for the rest of them. Okay, so this is basically our base case here. We pre-fill those in. What about the rest of these subsets? So remember, this is just 1, this would be, 1, 5, this would be 1, 5, 11, etc. Can these sum to 0? If we just have a subset of 1, can it sum to 0? Yes, but just by taking no elements. Same thing here, if we take no elements, we can sum to 0. Okay, great. So we have our base cases done. Now to meter the problem. So what about here? If our target is 1, using the array of, just 1 here, can we sum to target? Okay, so how do we figure it out? Well, our new target basically becomes, 1 minus 1. 1 minus 1. So was it possible in the first place to, sum to 0? Yes, it was, right here. Okay, so therefore in this case, it's true. But we don't just consider this, the 1 minus 1. We also consider the case up here if it was already calculated. So up here, the row above, it means were we able to calculate to this target already beforehand? Okay, and if not, could we use this value to now calculate to the target? Okay, since previously we were not able to calculate to 1 with subsets, we check can we use this 1 to be able to sum to target, and we can. So basically this becomes like that here, false or true, and obviously it's true. So same thing here. Using this, subset of 1 here, can we total to 2? Okay, how can we total 1 to 2? Well, 1 plus 1 is 2, so we want to calculate that. Is there a way, have we already calculated a way to add up to 1 so far? Okay, and the answer is no, because if you look at 2 minus 1, which is 1, so we look at 0, 1, were we able to previously calculate target of 1? Nope. So, and also we were unable to previously calculate 1 here, so this becomes false. So basically the DP formula becomes row column. So DP formula basically becomes so DP of row minus 1 and column. First we check what without including this value here, was it this target already calculated, or if this is false, we also want to check now using this value, can we calculate to target? And how do we do that? Well, we take the difference of what we need. So DP row minus 1, because we want to check the previous calculations that just happened, and the difference of what we need. So it would be column minus nums row minus 1. What does nums row minus 1 mean? Well, basically our values here. Okay, so this is kind of off by 1. So like 1 here is index 0, index 1, index 2. Okay, and here the 1 is index 1, 2, 3. So it's kind of off by 1 from our original num. So that's why I do minus 1 here. Okay. And remember, we do this, okay, because it's basically target minus value equals remaining, the remaining we need. Okay, and we want to calculate, we want to check how we calculated the remaining we need. If not, then we cannot use this value here to sum up to target. Okay. So that's our DP formula here. And using here, we can slowly build up this whole array. And eventually, at the very last position here, it should be equal to true. And we check this very last value here if it's true. If we were able to create a subset that sums to 11. Okay. By using this formula. So let's use an example where the result is false. So we have this array 552 equals 12, and half of that is 6. But obviously, looking at this array, we can't sum to 6. So yeah, let's fill out our base cases here. And here would be true, true, true. Okay. So here, are we able, using this 5, be able to sum to 1? Well, obviously not, but let's use our DP formula to check if we can. So, did we previously able to get to the target 1? Nope. How about when we use this 5 to target to 1? So 1 minus 5 is -4. Obviously, we can't have negative indexes, so this is going to be false. Okay, you cannot use this 5 to sum to 1. And remember, every element in nums is positive. And what about same thing here for 2? We were previously unable to calculate to 2, and using this 5, we cannot add up to 2. So that's going to be false, false, same here. And this is going to be true. Okay. While we were previously unable to calculate to 5, using this 5 here, we were able to sum up to 5. And 6. So we were previously unable to go to 6, calculate 6. So now let's use this 5 to see if we can try to calculate to 6. 6 minus 5 is 1. Have we previously calculated a 1 so far in our subset? Because we could really use that 1 right now to calculate to add up to 6. So turns out nope. So that's false. And here it's pretty much going to be the same. And yep. And okay, now let's get to this 2 here. So using 2, can we sum up to 1? Nope. And also 1 was, we were never able to calculate to 1 even without this 2, so it's false. This is obviously true. And here, can we sum up to 3? We can't, because we really need a 1, but we just weren't able to calculate to it. And same here, we need a 4 minus 2 is 2, we needed a 2, but we don't have it. Now we're up to 5, nope, we don't have a 3. We're up to 6, nope, we don't have a 4. So therefore the answer to this is false. Okay, I hope that makes sense. So I think I'll get to code in here. So yeah, we have our target, and now let's build our DP array. DP is going to be equal to false times length, or not length, target plus 1. Target plus 1, because if our target is 11, we want to include a 0, so I'll have 12 columns. For I in range and nums plus 1. Okay, plus 1 because we need to account for this empty array here. Okay. So now let's include our base cases here, like here and the first of the columns. We already have them all false here. I default to false, but let's fill out these columns. Okay. So for I in range, length of DP, dp of I 0 can be true. So now the first column will be all true. Okay, now let's get to calculating all these other elements in this table here. So for I in row in range 1, we skip this first row here because that's our base case. Okay, and we're going to start from the first row here. Len dp for column in range dp 0. We're going to have our check 1 and check 2. So basically this is going to be check 1. Were we able to previously calculate this target, without taking this new element into play? And this is check 2. So taking this element into play, can we use this element to sum up to target? Okay, so that's what check 1 and check 2 are going to be. So we default false for now. If check 1 is going to be equal to dp of row minus 1 and column. So we want to check basically the row up here first. And also what we want to do is if column minus nums row minus 1 greater than or equal to 0, because we want to make sure we're still in range. Okay. We want to check if we're still in range. Because column, the value could be like 2, but this value here could be 5, and 2 minus 5 is negative 3, and we don't have negative, so that's invalid there. So if it's in the range of that, have check 2 be equal to, let me just copy this here, dp of row minus 1 and column minus nums row minus 1. Okay, so now finally we're going to assign dp of row and column is going to be equal to check 1 or check 2. And if either of these are true, or if one of these is at least true, then have this be true. Okay. And finally, once you've calculated everything in our dp array, we're going to return the very last element. So return dp and dp minus 1 and dp minus 1. Okay. So I'll try running the code. Cool. I'll try another test case here. And by the way, the runtime of this is going to be O of n squared. So O of m times n, where m is the target length and n is this nums length. I'll try submitting. Okay, great. Thanks for watching.